Time series analysis is a critical part of operational data analytics. Frequently, an operations engineer will apply a well-known TSA technique to operational data, expecting to get useful or usable insights out of the box. We shall demonstrate in this talk that many of the TSA techniques are not very effective when applied to operational data and will present alternative techniques. A simple web search for time series analysis reveals the long and rich traditions that encompass the methods included under this umbrella term. The simple mean standard deviation-based outlier detection is one of the most popular methods of TSA. Despite its simplicity, it can be very useful on certain datasets where the observations can be reasonably modeled as a random process with a known distribution with a well-defined mean and variance. Although this is a reasonable approximation for many physical and social processes, including economics and financial metrics, this is not particularly true for operational metrics, which typically have idiosyncratic behavior depending on the services that are running on particular systems. For example, with some systems, we expect the CPU usage to spike periodically when the system performs some scheduled tasks. Such spikes do not last for a long time and do not adversely affect the health of the system or the service. However, such a behavior would undoubtedly yield a huge volume of false positives with a moving average-based method. The primary obstacles for such simple methods arise from the tacit yet fragile assumptions that the observations are stationary and some transformation of the observations can be approximated with a normal distribution. In the analysis of multivariate time series, clustering is an important problem. Again, popular and proven methods such as the dbScan clustering algorithm are among those that practitioners pick as the first option. However, the success of such clustering methods depends heavily on designing a suitable similarity metric. Naive methods of defining the similarity metric such as Euclidean distance on vector representations of the signal ignore the stochastic nature of the observations and are prone to curves of dimensionality. This leads to significantly suboptimal clustering results. In this session, we will explore the challenges and pitfalls of using these and other popular TSA methods on operational data and discuss more suitable alternatives.